Welcome back. We've been talking about air pressure and the atmosphere, that thin layer of air around the Earth, and especially the troposphere, because that's where the weather is. That's where all of these clouds are. Air pressure is a big deal in weather because it's air pressure, differences in air pressure that drive the weather. The reason these clouds form in the first place and the reasons these clouds move in the directions they do and swirl like they do is all about differences in air pressure. And today we're going to take a little closer look at air pressure and how the patterns and changes in air pressure determine weather.
So you're going to have three activities today in Cami, and I'm going to kind of walk you through and get you started with one at a time. I would recommend that you either maybe do split screen on your Chromebooks, or if you have the luxury of having multiple devices, put the video on one and where you can stop it and start it as you need to. You can get away with doing it on one device and listening closely to me and then following through with what I do. And also most of the instructions are on the paper also. But so this first one, these lines are called isobars. Isobars are lines that connect all of the points that have the same air pressure. So somebody went through and figured out where all those points are. This is the 1016 millibars isobar. Iso means equal, bar refers to barometric pressure. 1012, 992 is that little circle there, 996. The reason that's important is because once we can identify differences in air pressure, we can make a lot of predictions about the weather. Because I know where the air pressure is low, and I might as well write that in. I'll write. Where the air pressure is low, I'll put an L there. That tells me a lot. And 992 is the lowest on the map, so I know that's the low pressure. Where the pressure is low, that means the air is rising. Rising air makes clouds. And whenever you have a low pressure center, that's what that's called, you're going to have cloudy skies, and you're going to have precipitation. It could be rain in the summer, snow in the winter. If it's out over a tropical water, it could be a hurricane. So there's how it actually comes to be on any given day is different. But low pressure is always going to mean cloudy skies, probably for the whole day, not just a quick passing shower. I see 1016 is the highest air pressure on the map, and so I know that's going to be my high pressure. And I know high pressure means the air is really pushing down. If the air is pushing down, it can't make clouds. It takes rising air to make clouds. So I know this is going to be sunny. I know a couple of other things too, because low pressure is rising air, creates kind of a vacuum. It draws air in from the outside, and that air we call wind, the air drawing across the surface. The wind is going to blow into a low pressure and counterclockwise. High pressure, the air is pushing down. It can't go through the earth, obviously, so it spreads out. So around a high, the winds blow
counterclockwise and out. And often the
strongest winds will be like right here between a low and a high, where you have the high pushing the air this way and the low sucking the air that way, and they kind of add to each other. So a couple of things to point out about isobars. They usually loop back, but sometimes they go off the map, and so this probably loops back around somewhere, but our scale isn't big enough. Isobars never cross. You would never have the 1016 line and the 1012 line cross, because that would mean that point is both 1012 millibars and 1016. That doesn't even make sense. So they're never going to cross. Work through the rest of these questions. This is the way the isobars are usually drawn. There's a 4 millibar separation between two lines. Answer those questions, and that should take you about 5 minutes maybe. And come back and see me when you're done with that.
Okay, so you probably finished those questions, and now we'll move on to the second one. I think this one is called Surface Pressure Map, as in the files, Cami files. This time we have the data, the raw numbers, and we have to draw in the isobars. We have to figure out where it is a certain air pressure, and we have to figure out the patterns. So the first thing I do when I look at a map like this is I want to figure out where the highest pressure is. And I look at numbers and I see 1,024 is the highest pressure. So I got 1,024, 1,024. So this area is a high pressure. And again, I know that's going to be sunny skies. So just to remind myself, I'll draw a sun. Obviously clear skies, sunny skies if it was daytime. Starry skies if it was night. And then I want to find the lowest pressure too. And if I look around 2012, none of these are very low pressure, so I wouldn't expect any like extreme weather. 1008, 1008. So this looks like an area of the lowest pressure at least. And so I'll put an L there. And I know this is going to be an area of clouds. Now we're going to try to figure out how the air pressure changes. And first I'll draw in the 1008 millibar line. And I know it goes right through that town and right through that town and right through that town. I'm going to draw it in black. So that's the 1008 millibar line. I wonder if I drew it thicker, if that would be better. I'll try it thicker on the next one. And moving up, we usually go up by 4s, so 1012 will be the next one. And I can see it's going to go right through this town and 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 this town. And then the next one would be 1016. Oh, I messed up over here. I'm going to have to erase that because this is 1012 also, so that must loop around like this. Did I miss anything else? That looks better. And now the next one is 1016, and if I just pick somewhere to start, 1016. And it probably circles back over here. Since I'm close, I'm going to make that assumption. It goes off the map, so I don't know for sure. And then the next one would be 1020. But now 1020 is over here. And if I just draw and there 1016 is also over here. I guess I forgot those, but I don't know where that goes because it's off the map. And then 1024 would be like that. So I'm going to pause it here and you catch up with that because things are about to get much more difficult. So I need you to get on board with this.
Okay, so hopefully everybody drew that in, and that makes kind of sense. Remember, this is a low pressure, so this is rising air. The winds, I could have drawn in winds. We didn't have to, but I could have drawn in winds because the winds are going to spiral counterclockwise in the northern hemisphere and into a low, and clockwise and out of a high. I didn't want to mess you up, confuse you even more, but that's what would be happening. The lows suck air in and the highs blow air out. This is like a pile of air pushing down, and this is rising air, and that's what makes the clouds. So these isobars were easy because the lines went right through the numbers. That's not always going to happen. In reality, you're going to have to figure out where that line goes. And let's go to this next one. So we're going to try the same idea here, but it's going to be a little bit tougher. We start off the same way. I want to find the lowest pressure. And it looks like 995 is the low, so I'll put a low right here. And remember, that's going to be cloudy skies because that's rising air. And then I'm going to find the highest pressure on the map. I see 1017, 16, 18. It looks like right here is the high. So I'm going to put the high here. And remember, that's going to be clear skies, because that's air pushing down. And if it's pushing down, it can't rise, and it's rising air that makes clouds. Now, let's see if I can move that down so we can see some instructions. We're going to draw in isobars for 996, 1000, 1004, 1008, 1012, and 1016. But we're going to have to interpolate. That means we have to figure out, it's not always going to be evident. So, like, I know 996 goes right through that station. That's a station symbol. And I know it's going to go right through that one. But those are my only two 996s. I have to figure out where it goes in all the other spots. And I do that by comparing numbers. So I'm just going to start somewhere. Between 1,000, it's 1,000 there and 1,001 there. Would it be 996 between those two? Nope. But how about between 995 and 1,000? Well, yeah, because if you think about it, it's 995 here. It would be 996 right about there, and 997, 998, 999, 1,000. Between 995 and 9999, yeah, it would be right about there. And it would be right something like that. Now we can connect them, and we get a loop. I know it goes down through here, and between 995 and 998. So it gets harder because the numbers aren't exact. They're not going to go through every station. Some of the stations are going to be between your isobars, and some of your isobars are going to be between your stations. And you've just got to kind of figure it out. Taking them one at a time. The next one would be 1,000 millibars. And I know it goes right through that town. It's going to go close to that one. Oh, and it goes right through this one. And it goes right through this one. So that gives me a starting point. Now I'm just going to look, here's 996, here's 1,001. 996, 997, 998, 999, it would be 1,000 right about there. So I know the line is going to head that way. 998 and 1,002, well, halfway in there, in between, it would be 1,000. It goes right through that town. How about between 1,002 and 1,006? No, it doesn't go in there. It must go between this 996 line and 1,002. And it loops back around. We should also be labeling these. So 996, 1,000. See what you can do. Try to finish that. Draw the 1,004 millibar line. And then you're going to jump out here to the west and draw 1,008, 1,012, and 1,016. And I would work backwards when I got out here. I would do this one first, this one second, this one third. And then there's a couple of questions at the bottom. These are wind vanes. This shows the wind going in that direction. This shows the wind going in that direction. So think of these as arrows stuck into the town. That's the direction. This is a wind coming from the southeast. This is a wind coming from the east. This is a wind coming from the northeast. Okay, see what you can do. Submit those. I would like them done by Monday. So hopefully when we come back. But have a good Thanksgiving. Good luck on the test tomorrow. The test tomorrow is going to be all questions you've already seen, either on quizzes or on that chapter review. So it shouldn't be too tough. You get one shot, one sitting. No, don't take a break and come back later. You get one shot. Have a good day.